Welcome everyone. In this video I'm going to go over an exam problem from 12.5b. So this has to do with planes and whatnot, as it's shown in a previous exam. So in this case actually there were a lot of problems to choose from. I decided on problem number 2 here from fall semester 2016, and I'm going to do part A and part B. They actually both have to do with 12.5. And so let's go over this. The first part A, right? Find an equation of the plane that contains these 3 points. So we need to remember, okay, an equation of a plane. What does that look like? Well, it should look something like A times x minus x naught, plus B times y minus y naught, plus C times z minus z naught is equal to 0. So there's an equation of a plane, and we have to remember where do all these things come from. So x naught, y naught, z naught is a point on the plane. Well, in this case we have 3 different options, and kind of any of them that you choose, that'll work out fine. So I could go ahead and, maybe thinking about partial credit and stuff like this, maybe the first thing I do is do, let's see, x minus, and I'm just going to use p here, so minus a -1, so that's going to be the same thing as plus 1, b times y minus 4, plus c times z minus 2 equals 0. All right. The next thing we have to ask ourselves, okay, where did this a, b, and c come from? And those were the components of a normal vector. So I need to figure out how can I get a normal vector to this plane. And so let me go ahead and do a quick little sketch here about our situation. So I have these 3 points that lie on some plane. So here's maybe P, here's maybe Q, and here's maybe R over here, or something like this. And I want to know what is the normal vector to this plane. Well, in order to get a normal vector, right, we know how to do this maybe back from our 12.4 days. If I have 2 vectors, I can get a normal vector to those 2 vectors thanks to the cross product. So I'm going to use something similar here. For instance, if I found the vector PQ, those are that's a vector on the plane there. And if I found PR, for instance, that's another vector on this plane. If I took the cross product between those 2 vectors, I would get something that's normal to both of them. Right? So this thing right here, and the claim is that vector is normal to the plane. So this is the normal vector that I want, and its components make up A, B, and C. So I'm interested in what are the components for this normal vector. Okay, so I have a little bit of work to do, but hopefully you understand kind of the saga of, right, what I'm going to be doing here and why. So first I want to find PQ, and I want to find PR. So those are my 2 vectors that I'm going to eventually take the cross product of. So let's go ahead and play this game here. I start at P and I end at Q. So I'm finding PQ right now. So I start at -1 and I end at 3. How many steps did I take? Hopefully 4. I start at 4 and I end at 1. I took -3 steps. I start at 2 and I end at 0. I took -2 steps. All right, how about PR? So I start at -1 and I end at 0. I must have taken 1 step. I start at 4 and I end at 7. I must have taken 3 steps. I start at 2 and I end at -1. I must have taken -3 steps. So there's PQ and PR. So that was my first step, is to find these vectors. Now let's go ahead and take the cross product between these things. So this is going to be our n vector right here. So the cross product, so i's, j's, k's. I'm going to have 4, -3, -2, 1, 3, -3. And when I take that cross product, I'm going to have stuff with i's, minus stuff with j's, plus stuff with k's. Let's go ahead and do that. So I'm going to cross off the first column and the first row. When I take the cross product here, let's see, I'm going to have 9 minus, and that's going to be a -6. So that's going to be plus 6. All right, now let's go ahead and cross these off here. When I cross off the second column and the first row, I'm going to have -12 minus -2. So that's going to be the same thing as -12 plus 2. So plus 2 here. All right, let's go ahead. The last bit here, first row, third column, that's going to be 12 minus, and let's see, -3. So that's going to be the same thing as plus 3. And so my vector is 15. And let's see, this would be -10, but there's that extra negative sign, so that's going to be 10, and then 15. So 15, 10, 15. So those components right there make up A, B, and C. So my final answer is going to be 15 x plus 1s plus 10 y minus 4s plus 15 z minus 2 equals 0. So this is one possible correct answer, but remember there are actually infinitely many correct answers here. If you'd like to, for instance, if I went ahead and divided through by 5 on both sides, for instance, 0 divided by 5 is still 0. And on the right-hand side, if I divide this first term by 5, I'm going to get 3 x plus 1s. 10 divided by 5 would be 2 y minus 4s. And 15 divided by 5 is going to be 3 z minus 2s. So here's a different equivalent answer to the one that we had before, right? So there are indeed lots of correct answers to this thing. But so here's a couple of them. Either one of these would yield 100% for this problem. All right, that's part A. How about part B, right? So we can find an equation of a plane consisting of 3 points. Part B, find the shortest distance from the point 1, 1, 1 to the plane 2x plus 3y plus 4z equals 5. So in this problem, right, we have to remember what is the distance formula between a point and a plane. So if you do remember it, that's great, right? So distance is going to be equal to, and this is going to be really the magnitude of the dot product between n, that's the normal vector for this plane, and I think in our video note, in our notes or whatnot, I think we maybe had like RP or something like this. But in this case, right, we don't have a P, like if this was the point P, this is A, so I'm going to do RA divided by the magnitude of the normal vector. And remember, we went through a whole process of developing this formula, right? This actually has something to do with the projection, right? It's the projection. I'll just draw, the quick picture again here. So this is A. Here's the vector, maybe R, that's somewhere on this plane. So if you have RA, that's the vector that goes here. And this is the projection of this vector onto the normal vector, right? So if here's our normal vector right here, and if I take this and I project it onto this normal vector, nice 90-degree angle there, whatever that length of this vector is right here, that's the distance that we're looking for. So again, this really has to do something with a projection of this vector RA onto the normal vector. That'll give us this distance, and well, you take the magnitude of that and you get the distance. All right, so let's go ahead and solve this. I need to start collecting things, right? So first of all, I need an n vector. I need this normal vector. So let's go ahead and write that down. So our normal vector, right, that's given by the components or the coefficients next to the x, the y, and the z. So that's going to be 2, 3, 4. So there's our normal vector for our given plane. Now I already know what A is, so in order to find RA, I need to know what R is. And R is just some point that's on this plane, right? And there are lots and lots of options. And really the amazing thing about this formula is that no matter which R you pick, you get the same result, which is pretty remarkable. So I'm going to choose a point, R, that lives on this plane. So my favorite one is going to be 1, 1, 0. And the way that you check and you see that this is an actual point on the plane, right, is you plug in 1 for x, 1 for y, 0 for z. And when you do that, you get 2 plus 3 plus 0, and you ask yourself, does that equal 5? And if the answer is yes, then that point lives on the plane. So this is a point that lives on the plane. I'm going to give you guys one more. You could do 0 here, 0 here, and then the x value would have to be like 5 halves, right? Because this would give you 0 times 3, 0 times 4. When you add those together, you get 0. And you have 5 halves times 2, well, that's going to give you 5. So does that equal 5? Absolutely. So here are two different options that you can have. I don't like fractions so much, so I'm going to do 1, 1, 0. So here is a point that lives on the plane. So now I'm going to find RA. So that is, I start at R and I end at A. So I start at 1, I end at 1. How many steps did I take? 0. I start at 1 and I end at 1. How many steps did I take? 0. I start at 0 and I end at 1. How many steps did I take? 1. So there is my RA 0, 0, 1. So now, in order to figure out this distance, I'm going to go ahead, take the dot product between N and RA. So that's going to be, let's see, 0 times 2, that's going to be 0. 0 times 3, that's going to be 0. 1 times 4, that's going to be 4. Now this right here, it happened to be a positive number, but it could be a negative number, and it's important that you turn that positive. So that's why those absolute values are there. Divided by the magnitude of n. So that's going to be the square root of 2 squared, right? I'm looking at n here. 2 squared plus 3 squared plus 4 squared. So that's going to be, actually let me start a new line here. In the numerator, we're going to have 4. And in the denominator, we're going to have the square root of, let's see, 25 plus 4 is going to be 29. So that's going to be 4 divided by root 29. So there is the distance between the point 111 and the plane 2x plus 3y plus 4z equals 5. Alright, so this was a little bit of a longer video, but 12.5 stuff is difficult, right? There's a lot of different problems that we can ask. So here's a couple of them. I hope this has been useful. I'll see you guys next time.